Yeah. Oh, thank you, Abby. Yeah, so again, please use the chat to chime in as we go through. Um, and here's just a quick slide about how you can join our work stream of the incubator if you're interested. We've got our excellent admin person, Abby Scott, on the call here. She's also the person who sent the invites for today. So if you would like to be to talk about these issues further, we have monthly meetings to discuss papers and developments like laws around GDPR, etc. So if you'd like to be involved, then yeah, please send Abby an email and she can sign you up to the mailing list for that. So I've got 4 topics to talk through, and I doubt we'll get through them all. Well, at least if we have a good discussion, we probably won't. So with 4 topics for us to talk about, and I've done a few kind of prompts for each one as directions we might go, but obviously feel free to take it in any direction you wish. And the first topic for discussion today would be, what are the unique selling points of AI and ML methods? And in particular, where can these sometimes be detrimental? And this kind of covers some of the issues we spoke about earlier. There's a few prompts here that might be interesting for the speakers. But perhaps you'd like to start, David. This is probably one where you could have a good contribution.
What number 1, Sam? On explainability and black box, or
in general, that these are just ideas. Feel free to take it however you want.
Yeah. So maybe just to comment on, I think it's a long way to go with on the explainability front. There are lots of people working on the field, but it's only probably a small proportion of those people generally in the machine learning area. But the idea of replacing a highly complex deep model, where much of the work is nowadays, with a much simpler explanatory framework, perhaps a symbolic framework based on logic, or a Bayesian framework based on Bayesian networks, seems to me entirely feasible and one way of tackling it. So it's only an approximate model, but it's a model that gives you enough information to understand where, broadly speaking, what the deep network is doing. Personally, I don't have as much of a problem with the so-called black box issue, if I can see that on and obviously lots of caveats, particularly highlighted by Laura's talk. If on a very large data set, I'm finding that I'm getting very good performance, then personally I'm quite happy to, I would feel reasonably confident about taking the advice or the recommendations coming out of these systems as being actually useful, but without knowing precisely how it came to it. What is the causal structure that gave rise to the probability distribution on which my diagnosis is going to be based? And I think we may just have to accept that sometimes actually it's a very complex combination of things, including genomic data and imaging data, that came to that diagnosis. But provided the preliminary work's been done to demonstrate the performance level, then one has to have a certain amount of trust, modulo the kinds of problems which we just heard about. And Laura talking about utility does seem to be something that's completely ignored by an awful lot of the work in machine learning. The utility is really important and it's often just ignored.
Yeah, it's really tricky, isn't it? Because I'm playing devil's advocate slightly with some of the points I raised in my talk. I don't think it's quite as clear cut as I made out it to be. But I do think that we need to all be on the same hymn sheet with what we mean by external validation. I have real concerns that if we try the same methodology on a different data set, some people might think that's external validation, and that's not. That's testing the methodology on a new data set. But I think if we're all convinced that what we've done is actually external validation and our model works well, then some element of not perhaps being able to see all of it is kind of okay. Because if you, for example, and excuse the stats here, but if you fit a spline-based approach for continuous variables, you can't really write that down. It looks horrific. So it's not, and that could be for logistic regression with a spline for age, maybe. So it's not just the AI approach that has complexities, it's all of the approaches. We just have to be convinced that we've done every step along the development pathway to be convinced that our model is not only correct, but also clinically useful.
Yeah.
Else, do you have any thoughts on this? As like, as someone I might describe as almost like an end user of these tools. Oh, we can't quite hear you, Els. I think you're on mute. There we go.
Yes, sorry. Yes, I think so. I mean, I think in my area of clinical expertise, which is self-harm, I think in terms of prediction, it's been very cool. One thing people want to do is to predict when someone self-harms, or if someone has suicidal ideas, who is eventually going to kill themselves. And there are all kinds of problems with with power and things kind of like that. But also the static idea that a set of characteristics at time 1 is going to predict an event at time 2 seems to me very simplistic, because what happens in terms of self-harm or suicidal ideas is that people live in the real world and things change, and 2 weeks later their mother could be killed in a car crash, or their son could be sent to prison for drug dealing and things like kind of like this. So I once saw a statistical prediction model that had taken some of the techniques based from the weather. Can predict the weather. The most you can do, well, you can say it's going to be hotter in the summer than it is in the winter, but you can't accurately even predict the weather kind of more than a day in advance. But I think the kind of thinking around the way that we try to predict the weather, it should be the kind of the thinking that we start to apply to how we predict human behavior, rather than thinking a set of characteristics is going to predict something 12 months later, other than at the level of, yes, it is going to be hotter in the summer than the winter. And that seems to me to be where we are at the moment with prediction tools for mental health, because they don't take account of all these kinds of changing events that kind of happen to people. But that's a layperson's kind of contribution.
I noticed there was a question in the chat from Corey, who said, what do we get from large data sets that you can't get from appropriately drawn samples? Maybe Laura, maybe this is one for you.
I was hoping you weren't going to ask me, because I'm not sure. So there's obviously more scope within a large data set to do more, I don't like the word clever, but you can do a different variety of things with a large data set. If you've got a small data set, you have to ensure that you've got suitable power to look at all the predictors you're interested in, whereas the bigger the data set, the less concerned we are. I would still always advocate doing a sample size calculation, even if it proves that you've got 2 million people more than you need. But with a large data set, you do have scope to do a bit more investigation about potential predictors. And also, it depends on how the large data set's been built or put together. But if, for example, it's a combined data set of multiple GP practices or of multiple different CCGs, you could consider treating those as separate data sets. And then Richard Riley's work on IPD meta-analysis and the approaches for prediction modelling with multiple data sets might be of use, because you could think about all the different GP practices as different data sets and do some powerful modelling approaches like that. So Richard Riley's paper and Thomas DeBray's work on prediction modelling meta-analysis is the way forward in that case.
I guess on the sort of negative side, you with a very large data set, very difficult to curate it to the extent that you remove corruption. You can't all, it's more difficult to be sure that you haven't got errors in the data set, whereas with a smaller data set of appropriately drawn samples, you can actually curate and make sure that it's clean. This is going to be an increasing problem as we get access to larger and larger data sets more easily. How do you clean these data sets when they're so big that you can't do it with humans doing
it. Yeah, interesting. So perhaps we can move on to topic 2. Well, it's been 10 minutes already. Yeah, so if we move on to topic 2, that was about the teaching aspect of this. So the question here was, how should machine learning be taught to support students with both technical and healthcare backgrounds? And then there's a few talking points here, basically saying that I was trying to get across is very complex and involves a numerous amount of different skills. And really, how do you get that across to students in a meaningful way?
So if I can leap in here first, I would argue that it's not just machine learning that should be taught. I think prediction modelling as a whole needs to be taught. I'm aware that Keele University offer now a 3-day course on statistical methods for building and developing prediction models. And that welcomes people who are clinicians and statisticians. It was initially aimed just at statisticians, but clinicians are now joining the courses there, which is great to see. And certainly at Liverpool, we have a new MSc in health data science, and we have prediction modelling as part of that. We also have computer science modules that cover some of the machine learning aspects. So I think whilst it's important to talk about the machine learning aspects, we need to think about the bigger picture, and prediction modelling as a whole still has a long way to go. I agree completely that we need to teach people this process, but we also need to learn together. And it's been really interesting at Keele to have clinicians as part of the team and as part of the attendees to kind of hear what they need from us and what we need from them and how we can communicate better together.
Yeah, I would absolutely agree with that. For me, it's important to get some hands-on experience. I think for both people from a healthcare background and some technical computer science and statistics background, actually having some hands-on experience doing things yourself in a programming environment, and perhaps tailoring the environment to suit the particular background of the learner, actually gives a really good, the best possible feel of what it's like to work with data sets. I think there's so much to learn. That's certainly an issue. There are so many things, so much depth in any of the areas that it's actually quite difficult to present it in a limited amount of time. You could be doing it for years, and you would still have lots of material to cover, probably. And we all learn this stuff as we go through our lives. It's not a kind of one-off. You learn the stuff and then you know it for it. I think it's an ongoing process.
Yeah, I have to admit the final bullet point there that talks about ethics and governance made me break out in a cold sweat, because that's not anything I know anything about.
Yeah, and well, as we alluded to in the first talk, that this becomes a real issue and a real bottleneck to getting access to suitable data. And the processes are quite opaque from my perspective.
Yeah, I mean, I wonder if I could say something. I mean, I think it is important that people are aware of the ethics governance, but also I think data scientists or statisticians or clinicians shouldn't have to go through all this enormous bureaucracy. That's not what we're paid for. We're paid, I'm paid to do a certain role in research. You're paid to do a certain role in research. So in order to free people up to do the tasks that they're trained to actually do, there does need to be some simplification of the systems involved at the moment, or you do find that data or other people spend a large proportion of their time doing tasks that are basic bureaucracy, and that that their very expensive training is being put to waste.
And if I could ask, Els, with a clinical hat on for a minute, if you were going to use some of these prediction models with your patients, I mean, do you care how it's done, or should you care?
Yes, I think. I mean, coming back to suicide, I mean, I think if it was possible to build a model which could do something kind of like that, then I think it would be enormously valuable. but at the moment, I think we are quite a long way kind of from that, partly because the variables that go into building the model are dependent on very low quality kind of data. So we need to go right back to the beginning, to my point about discussions between clinicians and at the start of data collection in the NHS, which will enable us in the future to build these kinds of models. But at the moment, we're just left with things like gender, age, ethnicity, and those kinds of things. And so the actual predictors that might nuance these kinds of models are not there in the data to reliably record. So the models can't kind of predict what you want. But I don't see this kind of dialogue anywhere going on. And it's enormously important. It's not just in the area of suicide, but in lots of other areas of the health service.
Oh, thanks for the link there, Laura, for everyone interested in the Keel course. I agree, I did it a few years ago and it is fantastic. I would highly encourage everyone to go on it if you can. Okay, so let's look at topic 3 then. And this was about what use are checklists such as Tripod AI, coming back to Laura's talk, for improving the standard of reporting of models. So yeah, I'd be interested in any thoughts from the panel about that.
So you know my thoughts that Tripod AI, I'm hoping, is going to be awesome. But we need to do more than have the checklist. We need to ensure that people use it. So we really need to work with journal editors to ensure that it becomes a compulsory part of journal submission. I know that we all sit there and go, oh no, I've got to do a checklist. And I equally sit there even when I have to do a tripod checklist. But I think it's so important we do, to ensure that we report everything that's really useful for people who are going to use the article and use the model in future. I'm a little bit nervous to see there the train test split versus cross-validation listed, because I've read an awful lot of literature that suggests that train and test splits and cross-validation are not the preferred way of doing things currently, and the best methodology currently suggests bootstrapping is the way forward. But I'm happy to be convinced otherwise by those that perhaps know a bit more than me.
The reason I put those down, Laura, is it's a bit of a pragmatic problem. You know, if you want to do 1,000 bootstrap samples and your model takes, 50 hours to train, you're in trouble.
Yeah. Oh yes, especially if you've got multiple imputation going on as well.
Yeah. I don't know. What do you have any thoughts about that, David?
No, I mean, I'd like to know more actually about alternatives to Tripod AI. Are there many alternatives in that literature, Laura, or is Tripod AI the kind of gold standard?
Yeah, so Tripod's the gold standard, and in fact the only checklist for reporting the development and validation of diagnostic or prognostic prediction models.
Yeah.
But we're aware that it isn't specific for AI approaches, which have their own slightly different methodology requirements. Hence, the Tripod AI is currently being developed. And I should just say that Tripod AI is being built using a Delphi process. So that means that experts from around the world have been approached for their input on the checklist. So it's not just a few people sat around a room going, I think it should look like this. It's actually been sent out to a huge diversity of people, so that the checklist should, in theory, represent everybody's views.
Yeah.
There's also a ProBast one, right? I had an email about that a few weeks ago.
Yeah, absolutely. We're doing the same. I say we, I'm not involved in this, but I was just part of the Delphi study. But yes, so Tripod is the reporting guidelines for the development and validation of a model, and ProBast is the assessment of risk of bias for prediction models that have been built. And now we're looking at ProBast AI. So this is the assessment of risk of bias of models that have been built using AI approaches. So if you were doing a systematic review, this would be the main way of assessing risk of bias for an included model.
And do you have any thoughts about reproducibility, David? I mean,
yeah. I was going to raise that, Simon. I think it's a very special problem actually in the medical domain, in that in most of the literature that I follow most closely in computer vision, for example, the data sets are generally available, and the code is generally available, and so I can actually run the code on the data set and see it for myself, validate the result. Just I can reproduce exactly the results as they appear in table 1 in the paper. But in the medical domain, it's much more difficult, of course, because very often the data sets on which you're working are not generally available, and sometimes they are, but predominantly they're not easily available, even if they are available. So it's much more difficult to do that, and to compare on the same data set, to compare an algorithm on the same data set, a new algorithm. So that kind of research methodology is more difficult to pursue. I was going to say that the way in which a lot of the kinds of tests that the kinds of experiments that people do people tend to follow one another in the academic literature, in the machine learning literature, that you will look at a paper and then you have a new algorithm for doing something, and you will simply replicate the same set of tests that you saw being run, same set of experiments and metrics being produced that you saw being run in other papers. So there tends to be a lot of following rather than dropping back on basic principles of how these things should be done. But of course, those basic principles do eventually influence the literature, and people try to do things a little bit better. But there's an awful lot of not so great stuff out there at the moment in the way in which things are evaluated.
Yeah, I've seen some ideas along the lines of basically giving people access to a server where these things are available for them to test it out. But of course, there's a cost associated with that, which no one wants to pay for.
And there are challenges with that. So safe haven environments or similar, that's all well and good. But if you're trying to do a model, run your model on their data, it means you have to get your model somehow into their system. And that can be a nightmare, because systems I've worked with before, you have to type your code in from scratch and save it on their space. You can't just open your script and run it. So there are lots of challenges to be overcome with that sort of approach.
Yeah. And of course, it's fraught anyway, because you can actually write code which, whilst it doesn't simply read the data and dump it out, actually probes the data in such a way that you can find stuff out.
Yeah, absolutely.
That, you wouldn't want released, and so it's quite a dangerous thing to do, to allow people to run code on your server. I don't know what the technology is for stopping. You would have to filter the output to only allow people to actually output a very clearly defined output out of the organizational server.
So we've got 5 minutes left. So instead of moving on to another topic, perhaps it's good to go to any questions from the audience at this point. And there's one just come in actually, which is there any experience on how funders like NIHR view funding involving AI and ML?
Yeah. Well, I can say a little bit about that, having been on an AI funding panel. I think the data set's really important. So this last question on ensuring it's actually representative of the intended population is very important. So having a data set which is not representative is going to definitely be a limitation. So that's very important from an NIHR perspective. And in fact, I think that's probably one of the major lessons I've learned from being involved in this is the importance of the data set, and where that data set comes from, and the size of that data set, because it's so many of these data sets are actually quite biased in how representative they are of the population as a whole.
Yeah, I've reviewed a few program grants that were funded using AI recently for NIHR. And yeah, the ones that got through were essentially the ones that followed tripod, essentially. It told me what they were going to do and how they were going to do it and why they had to use that technique more than anything else. It was clearly explained.
Yeah, I think it's also important to explain what the AI is and don't just treat it as a black box. Actually explain what you're going to do and why it's appropriate. And it's not enough just to say we're going to use AI and expect people to think, oh, that's okay.
Yeah, and I think it's important, you know, that all those steps that I talked about as part of my presentation are at least considered. I'm aware that unless you're going for a program grant, you're not likely to have funding that's going to cover the systematic review all the way up to the clinical utility study. But I think it's important that you place your work within that framework. So just because you're building a model, that doesn't mean you're going to change clinical practice at the end of model development. You need to talk about internal validation, external validation, and then where you would lead to next. And that's the same whether you use, you know, logistic regression or AI or machine learning approaches. We need to place this modeling within context of the clinical area and also the development pathway.
Yeah, as I wanted to that, Laura, your final point there, the clinical workflow, how on earth is this thing going to get deployed, is very important. And if you don't think about that, then you know, that will help to steer the work that you do, the predictive work you do. The target clinical context is very, very important in doing that. And so it's quite important to think about that within these applications. How in principle
really
might it be introduced into clinical workflow?
It's really hard to get funding for that last bit though. I've discovered everybody wants you to build the model and show it's amazing statistically and it does fantastic things, and then you go, I've got this beautiful model, I've worked with patients and I know how it needs to look, can I now do a study to test whether it makes any difference to patients? And everybody's like, good idea but not fundable.
Yeah,
so I'm currently working on that.
Perfect. Well, yeah, we got just 2 minutes left, so I'll just move to the last slide here. And really, just thank everyone for coming. It's been an extremely interesting talk and discussion from my perspective, and hopefully everyone else's, since 2/3 of you stayed for the whole hour and a half, so that's fantastic. And yeah, again, just to quickly advertise our work stream on this, if you're interested, please contact Abby. She was also the person who sent the Zoom invite. And we'd love to see you at one of our future meetings to discuss issues like this in more detail. Yeah, and with that, I think I'll draw things to a close. And just thanks again to everyone, and thanks to the speakers, of course, for 3 fantastic presentations.
thanks, Sam.
Thank you.